Okay, now we're talking about area application. So this is using area, but also incorporating it with word problems. Okay, so we have these two squares here. One has 5 and one has 2 as the lengths. And I want to know what the scale factor of the side lengths is. So we've done this before. We've done this when we've talked about our proportions for similar triangles and so forth. So if I want the scale factor of my side lengths, that would be 5/2. The length of one side, so let's say this side, to this side, the ratio of that is 5:2. Now, the ratio from here to here is also going to be 5:2. If I look at the scale factor of my areas, well, I look at the most reduced form of my scale factor of my side lengths. And I know that 5/2 is as reduced as it can be. So the scale factor of my areas would be 5/2 squared, which would end up just being 25/4. So you can see how the scale factor of the side lengths relates to the area. All we have to do is say we have our scale factor of our side lengths as S1/S2. If I want to go to area, that would be S1 squared divided by S2 squared. So we just have to square the side lengths just like we squared the 5 and the 2 in order to get 25/4. Okay, if I want to find the shaded of the area piece, let's say we know that this is 5 units long and that this is 3 units long. And I want to have, let's say this is a pool with a little brick thing around it, and let's say that across it is 2. All right, so all the way around we have 2. So if that's the case, how long is this whole side and this whole side? Well, I know that this is 5 plus 2 plus 2, so it's 5, 7, 9. And then I know all the way across here that this is 3, and this is 2, and this is 2. So 3 plus 4 is 7. So when I find the area of the shaded piece, so it's everything in black, I first need to find the area of the whole thing and then the area of that thing inside. So we know that area of a rectangle is base times height. So we'll say area of entire, so I'll use A sub E would be my base, which is 9, and height, which is 7. So A sub E is 63. Now the area of the inside is also base times height, so that would be 5 times 3, which is 15. So the area of the shaded would be 63 minus 15. And then that would give you your final answer, so it would be 52. So let's say the area would be 52 feet squared if we were making this all in feet. Okay, find the area that a dog can roam if he's attached to a rectangular house that's 15 feet tall and 10 feet wide if the dog's rope is 10 feet long. So to do this, we draw our house. We know that this here is 10 feet wide and it's 15 feet tall. And we have a rope, he's attached to the corner, so we're going to make this where our dog is. And this is 10 feet. So in order to do this, we have to think about, okay, so if I'm here, I can go to there, and I can go all the way here if I were to make it a circle. So it kind of looks like a circle. We know that the radius of this circle would be 10, and that the dog can move all the way over here since this is 10, and he can move all the way over here since this is 15. So what we need to do is we need to find the area that he can roam. So I know that this is a circle, and I know how to find the area of a circle. That's pi r squared. But I'm only looking at 3/4 of my circle. So that's 3/4 of pi r squared. And it's 3/4 because we know that this would be a quarter and this is a semicircle. So I have 3/4 of my area. So I plug everything in. So 3/4 of pi times 10 squared. Area is 3/4 pi times 100, we can reduce this 3/4 and the 100. We know that 4 goes into 100 25 times. Times 3 is 75. So my area is 75 pi feet squared. So you would write your sentence, the area the dog can roam is 75 pi feet squared. Remember, words, problem in sentence, answer in sentence.